Supernova observation, first of its kind, using NASA satellite, as featured on viz.org. Astronomers at Ohio State University are looking to use a recently launched NASA satellite to monitor massive explosions in space, known as supernovae. When NASA's Transiting Exoplanet Survey satellite launched into space in April 2018, it did so with a specific goal: to search the universe for new planets. In a study featured in the journal Monthly Notices of the Royal Astronomical Society, OSU graduate students detailed how they were able to observe a supernova using NASA's TESS. The results offered new insights regarding the nature of such a cosmic event and the different elements it often leaves behind. A supernova is a large explosion that typically takes place when a star reaches the end of its life cycle, according to NASA. However, another type of supernova occurs in binary star systems, where two stars share a single point of orbit. One of these stars is often a carbon and oxygen-rich white dwarf, which tends to steal matter from its companion star. Once the white dwarf manages to collect too much matter, it will trigger a massive explosion. Observing supernovae from Earth has been difficult, given that they often occur in distant galaxies. To find out more about supernovae, the team developed a way on how to use TESS to identify and observe explosions in space. They focused their study on a supernova that involved a white dwarf star. One particular question the OSU scientists had to answer was whether white dwarf supernovae leave behind traces of hydrogen, which is a key building block of stars and other bodies in the universe. By their nature, white dwarfs would have already burned through the supply of hydrogen. This would make them an unlikely source of the gas needed to trigger a supernova. With the help of TESS, the team was able to identify hydrogen traces in the aftermath of a white dwarf supernova for the first time. Initially, it was believed that the hydrogen may have come from the companion star, meaning that it was not a white dwarf itself. However, measurements of the light curve from the supernova the OSU scientists observed indicated that the second star was indeed a white dwarf. A link to this article is shared in the description. Let's venture together into the universe. Thank you so much for watching.